Buenas tardes.
Un saludo, por fin. Me presento, soy Ignacio Maroto, Provost y Head of Academics de Westfield Business School. Ya tenemos en la sala a más de 50 personas, estoy seguro de que seguirán entrando muchos más. Me cabe el honor y el placer de poder dar a todos la bienvenida. Siempre solemos abrir cada bloque académico con una charla de interés de un ponente de primera fila y hoy tendremos la oportunidad de disfrutar de un apasionante keynote titulado La Tierra y las Estrellas, aprendizajes claves sobre el liderazgo. Nuestro invitado, Massimo Tarenghi, nos compartirá un recorrido que me parece fascinante de 40 años de trayectoria en su labor como astrónomo y su liderazgo en algunos de los observatorios más avanzados del mundo. Es una vida dedicada a explorar el universo y al mismo tiempo una experiencia que me parece única de liderazgo en entornos extremos que nos invita a muchas reflexiones, a reflexionar sobre la curiosidad para mirar más allá, sobre el coraje para avanzar en la incertidumbre de lo que está todavía inexplorado y sobre la visión para construir el futuro antes de que esté escrito. Invito a todos los asistentes a que abramos nuestras mentes, a mirar con asombro y a dejarnos inspirar por esta historia que conecta a las estrellas con la Tierra. Para presentar a nuestro invitado, a Massimo Tarenghi, tenemos a Rafael de Cárdenas. Rafael de Cárdenas es Chief of Innovation and Curriculum Content Development en Westfield y es también Chief Academic Officer en el grupo Prisma. Adelante, Rafa, bienvenido.
Muchísimas gracias, Ignacio. Y como Chief Innovation Officer, hoy estoy innovando mucho. Por ejemplo, está aquí la siguiente generación, que también se llama Rafael de Cárdenas, en el centro de la imagen, que va a decir hola, creo.
Hola.
Hola. Y tenemos, por supuesto, a nuestro invitado, a Massimo Tarenghi, que realmente, Massimo, es un honor tenerte aquí.
Un placer por mí.
¿Qué os puedo contar? Fijaros que también es una innovación en que esta sesión la hagamos. Normalmente el ponente está en un lugar con una computadora y yo como anfitrión estoy en otra. En esta ocasión nos hemos juntado y es porque resulta que estamos en la misma ciudad y nos hemos juntado en casa para hacer esta sesión pues más íntima, más cercana y también por la muy estrecha relación que nos une a Máximo y a mí. Voy a pasar al idioma inglés ya muy pronto para presentar a Máximo, que va a hacer su sesión en inglés. Máximo habla muy buen español, porque ha vivido en Chile muchos años.
No, solamente 45.
Pero se siente más cómodo haciendo esta exposición en inglés. Ya veréis que hay mucha cosa técnica acerca de su vida, de cómo lo ha hecho, de su carrera, y yo creo que mejor que lo escuchemos en inglés. De todas maneras, los que queráis escucharlo en español, vais a tener el intérprete disponible. Hay un icono con un globo abajo a la derecha, y ahí si pulsáis idioma español podréis escuchar la sesión en español a través de Gabriel, el intérprete, y si preferís seguir la sesión en inglés, vais a poder escuchar en directo a Máximo sin hacer nada. De manera que ya después de este preaviso ya me paso al inglés y seguimos la sesión en inglés con Máximo. De todas maneras, para las preguntas y la interacción con él posteriormente, podéis usar el chat y desde luego podéis usar el español perfectamente. Yo voy a estar atento al chat y ayudaré en el proceso de las preguntas y respuestas con Máximo, de manera que en el chat no os preocupéis escribir en inglés o en español sin ningún problema. Y ya paso al inglés. Welcome, Massimo. Really a pleasure and an honor to have you here with us. Let me briefly say a few things about Massimo because I want you to spend most of the time with him, which is the most important person here today. And let me say a few things. You know many things about him. You have read the CV, the resume, his amazing career. But when I asked him today, what do you want me to tell about yourself during my introduction, he said, please say that I'm an amateur astronomer. I mean, this shows how humble Massimo is because to me, he's the top astronomer in the world. And my opinion is based on facts. It's not only that I like him and love him as a friend. You can see his career and you can understand why I say so. But also it's very humbling because when he says so, he acknowledged how huge how immense is the universe, the stars, the planets, everything that is beyond planet Earth. And this has been his passion for his whole life. Devote his life, research and work to make of this a better world based on how to better explore everything that is outside planet Earth. Let me share briefly how we met, and because it was really impressive and magic as well. I was in the honeymoon trip in a place in Asia, and I was focused on my wife, actually, because that's a honeymoon trip. What do you normally do? And it was fantastic. But then one night we saw a very interesting person with a projector and like showing some slides about stars and planets. And then we were coming back from dinner, and then we saw this amazing gentleman there showing those slides. We started a conversation that continues until today about the stars, about what comes after death. Even one of the first questions that I asked Massimo is, oh, so you know a lot about the stars. What do you think about God? Does God exist? And this is one of my first questions to him. And also, of course, a few days later, if there's aliens or other lives in different planets, that was also one of my questions. But yeah, since then we continue this fantastic relationship. You will see in some of the pictures that he will show places that I've been with him, which are actually amazing. And just let me share with you briefly that why is important an astronomer, why is important an observatory. He will explain it much better than I. But I was impressed by visiting these places with Massimo, how people devote their lives, researchers there devote their lives to see through these telescopes what is, if there's a minimal change in the distance by observing, in the distance between one object in the sky and another, because this may imply that there's some attraction between these objects. So maybe there's kind of a correlation between those planets or objects. Also, by looking at the lights and if maybe there's something greenish, maybe you can imply that there's chlorophyll. If there's chlorophyll, maybe there's life. If there's life, maybe there's something worth exploring for humankind. So these are the kind of important things they do in these observatories. And with this saying, Massimo, I think you are an amazing human being and top astronomer in the world. And I'm really pleased that you are here with us to share many things that I'm sure are going to be inspiring for our students. Also to ignite one passion we inspire always you students, which is about aiming for the most amazing things in the world. You can do it. We can do it. And it's impressive how Massimo picked things that are almost impossible to figure out and understand. But he has been good at this for many years and continue being the best in the world. Thank you very much, Massimo, for sharing your thoughts and ideas with us.
Thank you for the invitation.
Please, if someone can tell me if you can see the slides with a sign or a gesture. 1 second.
Yes. Yes, Rafa.
Thank you. Yep. The floor is
Okay.
yours.
Time to go into space. This is a beautiful picture. At least I like this picture because it's my picture. Of the Milky Way and the Magellanic Clouds in the Easter Island. And this shows a little bit relation between all time and the universe. And this is something that had been fascinating me when I was a child. And I was 17. I decided that I was supposed to be one astronomer. And my dream was to be able to work in the biggest observatory in the world, because the second is the first of the last. So I've been lucky, because after many years and many things, I managed to build the biggest observatory in the world. And therefore, automatically, I was working there. Now, let me tell you a little bit what it means to be astronomer and what it means to be associated to telescope. when I was in Machu Picchu, I had the luck to have a guide that he was an amateur astronomer. And he took me to this place that is on the slide, that is observatory, astronomical observatory of Machu Picchu. And I was fascinated to see this stone. They were filled by water, and the astronomers that were looking the crossing of the star reflected in the water. And in this way, they were measuring in detail the position of the star, as well checking night after night if was something going on different from the previous observation. And a demonstration of the precision in which they were doing this observation is seen in this stone that you see on the left. Is a reproduction of the Southern Cross, the most spectacular constellation in the South Hemisphere. These four corners are the position of four stars that are impressive. Now, this shows that astronomy is something that fascinated everybody, king, emperor, normal people. In the whole history of humanity, there is no science that more interesting to us than to understand the beginning of a universe, its end, to understand where we come from and where we go. And another demonstration of this desire to explore the universe and understand better what is the story of the universe is shown here of the telescope that was built in 1900 at the time of Eiffel Tower in Paris. This telescope, it was built, and it was intended to look for life on the moon. Now we know that moon does not have a life, but this passion to try to see life, a universe, it was already there, and it was requiring to build bigger and bigger telescope. And I will show the end that we are very close to see life in the universe through telescope. There was happening also in 1920, a very big change of our knowledge of the universe. Mr. Hubble discovered that the Andromeda Nebula, a little magic thing that is not a star, is a little cloud in the sky you can see naked eyes, it was not part of our Milky Way, but it was a galaxy outside, a 2 million light year. And then he discovered that if we're going to fainter and fainter object, it was possible to see galaxy going away faster and faster from our galaxy. Means the universe was expanding. And that changed completely the way to understand our cosmology. And this required to build bigger telescope, because this 100-inch of Mount Wilson, it was good to understand what was going on, but not understand why. And so one telescope, a very famous, is a Palomar, built in 1949. I have to say that I have an association with this telescope, in the sense that when I was in charge of building a new telescope, bigger telescope, I always took my engineer technician there, like being a cathedral of science, astronomy, technology, and to understand how you transform a dream of being able to observe far and detail can be done involving new technology and involving management and invention that allowed you to go deeper and deeper. And this, why it doesn't change? Okay, this, if you look inside the polymer, and I've been many times there with my engineer, is impressive. The dimension is a monster that you say, well, we cannot be building a bigger one because it's too big already. And that was true. Matter of fact, the other people, other nation, Russian, European, builds a similar telescope, but they were not able to be bigger telescope. And in particular, European decide to do something that help astronomy, to go to South America, Chile. Chile is a fascinating place, and it's now known to be the best place in the world where to install telescope, because a number of clear night, the light of the lack of light pollution, and the altitude of a mountain where you can build your observatory is such that there are no other place in the world. There is one, Hawaii, that is good, but honestly is not as good as Chile. And let me show you a very interesting movie. This represents 3 years of cloud coverage. As you can see, there are a few places, Chile, Namibia, the Sahara, Australia, they have a limited number of night with cloud, but except Namibia and Chile, all the other low altitude. And it's very important to go higher enough to reduce amount of turbulence of the atmosphere. And Chile is now known to be the best. And Europeans, they decide to build their own 4-meter class telescope in Chile. And so I will show you what we have been building in this area called Atacama Desert. We start to build down here, La Silla, and also the American Las Campanas here. And this is because it's a desert, but there's still some water around. When you go in the middle, where we will show you later, there is nothing. And but let's go back here. And here there is a telescope in 1977, the European ESO, European Southern Observatory, built for facilitating the European astronomer to look the southern sky. I have a personal link to this telescope because I was the second astronomer able to observe with this big telescope after I've been spending 3 years in United States and Arizona observing with big telescopes. So they gave me 10 nights with this telescope. And when I came out, I went back to Geneva, was headquarters, I complained that the telescope was good, but it was not what the astronomer need a bigger telescope, a more performant telescope. And so I was punished by my arrogance in criticizing the best telescope of Europe in such a way that when the organization received 24 million, they say, oh, you're good. Okay, take these 24 million and do a better telescope of same size of this one is in the slide. This was costing 80 million. So I received less than a third of the money that had been used for this one. But we found, of course, not myself, my engineer and technician, optician, the way to reduce the cost of a telescope is this was 2 things. One is to reduce the weight of the mirror. It means to have a more thin mirror in such a way that it was not necessary to have a heavy structure, steel structure, and reduce to the minimum the volume of the dome. And this was possible using so-called alt-azimuth mountain that require the control of two axes by computer. And so the computer technology was able to help us to operate this telescope. And this telescope was based on a very sophisticated and totally new way to operate, to have such a thin primary mirror that was deformable under the weight. But under the mirror, the main mirror, in this case was 3.5 meter, there was actuators. And in the focal plane, we were able to measure the quality of the optical image, and we were deforming in real time, every minute, the shape of a mirror. We were centering the secondary mirror, and then more activity to be able to keep the optical trail perfect as the optician want. And this transformed this telescope in what the magazine, Sky Telescope, the most famous magazine in the state, say the best telescope in the world. And it was an achievement that was possible because we were going to the extreme of technology. Of course, the success of this telescope that for 24 million have destroyed my life completely, because after this, we received much more money, and we've been asked to build the biggest observatory in the world. And so I was transformed permanently in a manager of telescope and observatory. And so we've been engaged in having the biggest optical observatory farther north in this area that is the most dry place in the world, is absolutely identical to Mars. When you go there, and they've been with me there, if you take a picture, you change the color of the sky from blue to black, you cannot distinguish this place from a photo done on Mars. And this is a unique area. The VLT, where I've been building the optical telescope, the biggest optical telescope, observatory in the world, is only 12 kilometers from the Pacific. And then I will show you ALMA, that is a biggest radio observatory in the world, but this is at 5,000 meters in the Andes. Here you can see beautifully how fantastic is a desert Atacama that is almost always without cloud, for two reasons. The Pacific, there is a current coming from Antarctic, so it's very cold, and the clouds are very low level. On the other side, on the east side, there are the Andes that prevent cloud humidity coming in from Argentina and from Bolivia. And so this is a unique place in terms of number of clear sky per year. We probably have 10 days, 15 days, we see some clouds. And of course, when you want to do the best, you have to find the best mountain. And we found it in 1987, the best mountain was Paranal Peak. And this was incredible. As I say, this is Mars. But there was a problem. And there's always a problem when many of you are managing things. Management is to solve problems. And so if there are no problem, you are not a manager. And the problem here was very simple. We need a flat area of about 400 meters in diameter. Now, this mountain was beautiful peak. And how can you put 4 big telescopes on this mountain? And it's very simple. You take and you cut the mountain. So as you can see, in 1991, we decided to select this mountain. In 1994, we had already cut. We have removed 38 meters. We produce about 400,000 cubic meters of rocks from here, and we put here, and on the rock removed from here, we've been building the road. We did also space for the control room on the facility. And then in 1999, we have completed the construction of the observatory. I have to say that this project started in 1977, and we completed in 2003. I've been following this project from the beginning to the end. And this shows that you have to be patient. You have problem after problem, but you find a solution, because there is always a solution. And when there is no solution, you find a recovery plan that avoid the problem you are encounter. Well, here is might be an interesting photo during the construction. And this shows the complexity to build in the middle of nowhere. The closest place with some water is 180 kilometers away. We had to bring in water every day by truck. There is no electricity. We had to bring in and produce power locally. There is nothing of nothing. There are no insects. There's nothing. There are no vegetation. It reached a moment when I had to want more than 600 people working in this place. And from the point of view of logistic, and also from view of human relation to this kind of place, it was very difficult. I had to control, even when I was not there in Chile, I was in Europe I had to call back every day and check with some of the key people to understand how was the atmosphere, if they had any problem. And sometimes I've seen, even discussing about a soccer match or some other event, there was some tension, and I had to give order to go back to town, 200 kilometers away, because this was a very hostile place. And when you build 4 of these big telescopes, you put a lot of work on the number 1. And then there is a second one that to be done. And then a third one. And then the fourth one. And then there was all the infrastructure. So it was a very challenging, interesting. We had crisis. We had to break because we had a legal problem related to the property of this land. So when you build an observatory, a little astronomer, amateur astronomer like me, build observatory, you have to encounter a lot of the problem from optic, mechanic, software, logistic, but also legal, all this kind of thing. You have to be prepared, and the trick is to select good people working for you. Give to them the freedom to take decision, and give to them, and this is, I think I learned on myself doing for about 30-year management of big project, to give to them delegation, but if they do the mistake, take responsibility for the mistake with respect to your big boss. Never give responsibility to the people, but if the mistake is done by them in a bad way, you have to learn how to fire people. But let's talk about a more pleasant thing. Okay, when you build in the middle of nowhere, with no water, no electricity, nothing of nothing, you have to build the observatory with the telescope that are here on the top. You can see here all the earth that being removed from the top. The mountain was higher than this telescope. And then we had to build all the infrastructure, okay? And where there is all the technical part. And I also been building a hotel, residencia, that when we finished the construction of the telescope, I left 12 millions for building a permanent residence after I've been living for 10 years in a container camp. And we have been building the hotel here. And I don't show you the photo because you can look into James Bond movie, Quantum of Solace, that's being used for that. Is a most incredible hotel in South America with a big swimming pool inside. The serve to increase the humidity, typical humidity outside is at 3-4%. So we have also problem of climate that are not easy to solve. Here you have a beautiful picture of the land in Chile. At the end, where the arrow goes, is a border with Argentina, and this is the third highest active volcano in the world. It's called Yaco, and is more than 6,000 meters high. Now, it's very interesting. Yeah, it's very interesting to see now this mountain here. Now, this mountain is higher than Paraná. Paraná is 2,700 meters, and here is 3,000 meters. This mountain, when in the 80s we look for astronomical condition, was the best mountain for this region, but there was too strong wind, and we was afraid of the wind. And we decided to go for this peak, and it was a big luck, because now this mountain remain to be the best mountain in the world to build a telescope. And part of my life, I managed to convince a Chilean government when for 5 years I was operating as representative of this international organization in Chile, like an ambassador. I managed to have all this piece of land, 30,000 hectares, for free from Chile. And now we are building what we will show you later, the biggest telescope in the world. Now, let's go back to the Paraná, and I'll show you a little idea of problem. One, of course, so the main thing of a telescope is a mirror. This is a mirror in place in the telescope. It's a 8.2 meter in diameter, and just looks simple, easy, but it's not simple, that easy. Nobody have ever built a mirror of this size. And so this requires a construction, a factory in Germany to produce this disc of glass of 40 ton, reduced later on at 20 ton, to be transformed in our mirror. Now, just to give a feeling, this is a process of casting this. We have glass at 1,400 degrees. They have to go down at the room temperature, but it takes 8 months because they have to go down slowly. And when we did this thing, after 3 months, the glass was broken in many pieces. And then there was a second one done a month later, and again was broken many pieces. And see, there's a moment when you say, well, I have no mirror anymore. Well, I have no a glass to do the mirror. And so all the engineer of shot company, more than 15 engineers, they study the process and they managed to find a solution. I cannot say which one, but it's a very interesting solution. And then they produce 6 without any problem. And when it was reduced from 40 to 20 ton, had to be sent to Paris to be polished. And here is this 20-ton glass that for 2 years have been polished and cleaned the surface at the level of 20 nanometers. So I don't think that if you take this size of, let's say, Florida, the peak will be more than 2 millimeters high, just to give a feeling of the precision of the protection. And then, as I say, it was 4 years or 5 years after the casting of the mirror. But this was in Paris, and the telescope was in Chile. So we had to take this, put on the ship, go through the Panama Canal, arrive to Chile, taken away from the ship to a track, and then it was ready to go to the observatory and do the 180 kilometer that was necessary from the harbor to the observatory. And here is me that did this journey in 3 days because we were driving at 5 kilometers per hour. And unfortunately, the last 100 kilometers, there was no road. There was a desert. So we had some grader and flat the desert to let the mirror to arrive at observatory. And here is when after number 4, it was a little better condition, the road. But this to show once more how dry and how terrible or beautiful, depending on point of view, is the desert of Atacama. Now, why we have done all this? It's very interesting. At that time, when we were building this telescope, there was a competitor, was the Hubble Space Telescope. And there was an idea in the NASA, in the world, that space telescope flying above the atmosphere was doing better results than ground-based telescope, where the turbulence is killing everything. Now, here is what I've done in the first 2 months observation. At the right here, you have a 22-hour exposure of the Hubble Space Telescope. And here is 15-hour with my VLT. Now, this telescope is 2.5 meters in diameter. This telescope is 8 meters in diameter. Obviously, we collected more light, but the quality of the image is not so different. Of course, it's sharper here. So this has demonstrated one thing, and that is a very important lesson we learned. Space telescopes are good if they're operating in the domain where light is not arriving on the Earth. If we have light arrive on the Earth, optical and radio, we can build bigger telescope and be better than a space telescope. So this project demonstrated the complementarity between space telescope and optical telescope. Now we went one step further. We have introduced in our optical chain a mirror can be deformed 400 times per second. So we measure and monitor the turbulence of the atmosphere, and we have a possibility, even on the ground, to remove completely the turbulence of the atmosphere and have on the ground a telescope that is operating like space telescope. You can see here the space telescope and the ground telescope when you operate removing atmosphere turbulence. And that is dramatic change. Well, with this thing, we'll be able to do something more. And the success of this project have killed me for the second time in my life from amateur astronomer. And they sent me on the road to 400 kilometers north in the desert of Atacama, arrive at a beautiful Salado Atacama. Is a second salty lake in the world. This is the source of the lithium. 40% of lithium produced is coming from the water below this salty lake. And then we arrive to a place called San Pedro Atacama Oasis, where we have been together having fun. And this is the type of sky observed. This is my photo with just a normal, a professional Nikon camera with a 14 millimeter lens. And this is exposure of 25 seconds. Okay. And that shows the beauty of the sky in this area. And here we have built a radio telescope. This radio telescope requires to be located at 5,000 meter altitude, because this telescope works in the millimeter, sub-millimeter range, and is looking for molecules in the universe. And so we have an operation science facility at 3,000 meters, where we have all the control room. So we have to build this infrastructure, and then we have to have this control of all the telescope that are 5,000 meters, where nobody's there because it's very, very tough to be there, and also cold sometimes. And so here we operate like a Hubble Space Telescope, but the telescope is on the ground. And then we had to build a 40 kilometer of road to go from 3,000 meter to 5,000 meter. And before to building this beautiful road, that take me about 45 minutes to go from 3,000 to 5,000. I was used to go up and down from 3,000 to 5,000 on the terrain. I was talking normally 3 hours, 3 hours and a half with a lot of bump. And it was tough. Now it's much easier. And then when you arrive 5,000 meters, you can see the 66 antennas of radio telescope. These antennas are able to observe, as I say, molecules in the complete universe. We can map the presence of the water in the entire universe from the Big Bang to today. We can see, and we are seeing, molecules very complex, molecules that are the beginning of the life. So this goes back to this fantastic idea to look for life in the universe. This astronomy linked to biology is a fascinating new way to observe the universe. This is a huge antenna, and we have also a very interesting way to operate this antenna, because we can transport the antenna with a special transporter and place antenna over plateau, either all compact in 300 meters or in 12 kilometers. So we have like a zoom in the photographic sense of looking the sky in the deep way. Now, here is a very interesting, the 4 telescopes we have, Paraná, are this size. This is the size of collecting area of the radio telescope. And because the wavelength is longer, you need to have much higher area. Here is the Hubble Space Telescope. You see the change in dimension of a collecting area that been through, have been involved in construction, all this kind of thing. And this is fascinating. But you see, we are never satisfied. We want to have better. We want to have better and better. And that is what we are doing right now. And this is an interesting chart. Here, you see this little point. This is a telescope in Paris that showed the beginning. It was just a refractor. And then we start to, this is a Palomar. And then we've been building bigger and bigger. These are the VLT I showed to you. And now we are engaged in the construction of much bigger telescope, particularly European. We are building now the 40-meter European extremely large telescope. And this is not a dream, like also the American in Hawaii, they are doing the 30-meter, and also in Chile is a 25-meter Magellan telescope. This is not the dream, are real thing that in which we are involved now in the construction. And this will be the dimension of the 3 telescopes I was telling you that are in the construction. I want to just show you what the European are now in the process of erect. This is a cartoon, but we are not far from this. If you go into ESO, European Southern Observatory page, you can see the construction going on. We expect in 2029 to have a first light. And this will be a telescope able to see things that they were never been seen before. Let me tell you why we are spending more than 1.5 billion in building this thing, and then we will spend probably about 9 billion to operate for 50 years this telescope. Okay. Yeah, but going back to the story, for this big telescope, we need to find a mountain. I show you the picture of a mountain in year 2000. Now we have cut also this mountain. We are used to cut the mountain before to erect telescope. And what we are building is this kind of telescope. And you see what is the size of the thing that the astronomers are building compared to big things that have been done in the past. We are really reaching a level of major construction in architecture and technology. Now, why we need this? Because we want to go deep, collect more photo, but at the same time to see more detail of the universe. And here is the same part of the sky done with space telescope on the left, with the VLT parallel when we have this control of the atmosphere. And then at the right, you will see the same size of sky seen by new ELT. We will see detail that will never be able before. And we'll be able to do 2 things. One is be able to see planet around other star, of course, of our Milky Way. And we will be able to see if this planet has atmosphere, and if this atmosphere shows the presence of life. So with this telescope we are now building, American and European, we will hope after 2030 2030 to be able to see live universe. At the same time, we will be able to explore the universe from the beginning to our day. And you know that the universe, it was born with a big explosion, about 13.7 billion light years. And then the first star started 400 millions after the explosion. And we want to see the star. We want to see how this star or this galaxy or whatever it was evolved, and how is the history universe. Also, we want to understand a little bit better our universe. And here I want to show you this little thing that you see that here the universe expanding very rapidly, and then it starts to expand slowly, 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 and then now is accelerating in the expansion. This acceleration expansion and the thing that there is gravity inside the universe that is not associated with matter has been discovered with the telescope that I've been showing you that we've been building the last 50 years. And the result of this is very scary. Look here, the composition universe. There is this part that is 0.5%, and this part, the 4%, so in total 4.5%, is what we thought when I was at university in 70 to be the component universe. Now we have learned 96% of ignorance. We have discovered that there is a dark matter that represents 25% of the universe. You have no idea what it is. We know that has effect of gravity, but it's not visible, neither block the light. It's transparent, but exists. And it's this, this part that have conducted the expansion universe and the control universe. But now the universe is under control of the dark energy. They represent 70% of the universe. This is energy that is dominating the universe, and we have no idea what it is. And with this big telescope, we are under construction, and we will operate together with the big accelerator at the CERN in Geneva, able to reproduce the density and the temperature of the Big Bang. We will hope to understand the nature of the dark matter and dark energy. So I, as an amateur astronomer, I still like to know more that 5% of the universe, as I was learning when I was in university. And here there is a lot of things for young people to go in. Thank you.
Well, thank you very much, Massimo. Really, really, really impressive. Let me check I see you clapping hands and all kind of signs from some students about the session. Let me check in the chat if there's any comments or questions so far.
Oh, you're too confused.
I think I have to stop sharing in order for this to happen. So let me stop sharing. And then now we are not sharing. And let me check in the chat. But actually, now is the moment for you to ask questions. I think the best way is to write the questions or messages in the chat. So there's a first question here from Liliana Alvarado. So life in the space has any shape?
Okay, that's good. We do not know how and where is life in space. But if we assume that life is not so different from what we know of the beginning and life in the earth, we think that we have a possibility to detect this just observing the atmosphere and the light going through the atmosphere of planet around other star. And we are confident, and I'm sure personally, I believe that we'll find before 2030, 40, this life. It's very interesting. One Radio Caracoles from Venezuela called me for an interview when we discovered there was an exoplanet very similar, and asked me about the life and so on. And then the journalist asked me, well, but do you believe there will be life? He said, yes, I believe that we will discover life. But then he said, but you believe that we will see intelligent life? And I said, sir, when I look around myself, I don't think there is an intelligent life in the universe. What I'm only trying to say, I'm sure, because we are building an instrument and considering what we know now of the universe, we are sure that we will see life, the presence of life in the universe. Let me show you one thing very interesting. One colleague of mine have demonstrated there is life on the earth without knowing that. What he did, he looked at the moon after the new moon. And if you look at the moon 2 or 3 days after the new moon, you see the disk of the moon illuminated by the light reflected on the sea of the earth and going to the moon. That light is the light of the sun. It went through the atmosphere. And he measured with this 8-meter telescope the composition of that light, and he discovered there is life on the earth. And this is exactly what we will do in the telescope with other planets in other stars. Okay? So, what else?
Many questions also about life in other planets, of course. And there's one here very interesting. Anderson Corridor, he asks, if anytime you observe something that generates you fear and you preferred back then not to follow getting deeper into that?
Well, okay. You're talking about observing from the point of view as astronomer, okay, not as a point of view of manager. As a manager, yes, fear, but as astronomer, no, because if you are an astronomer or if you're a scientist, you are open of new things, or thinking you don't understand. That is the best thing that can happen to you, to look something and say, wow, I never thought about this. And the point is, there is nothing wrong in the universe. There's something wrong maybe in what we do with the universe. But universe is not a bad one. Okay. So no, I never had, I was encountering very strange thing in my life. One, for example, one of the things which I work a lot, and one of my major contribution in astronomy was that in the 70s, I studied distribution of a galaxy and universe, and with the two teams in parallel, we discovered that the universe is populated very small part. The majority of the universe is empty, and there's this big void, and we were very confused because we thought that the galaxy was coming more or less homogeneous distributed and so on. and we were not understanding, but we were not scared. We were start to think how it's possible, and the answer came a few years later when we have been able to map this light that it was produced at the time of Big Bang, when there was separation between light and matter. This was called 3-degree radiation. And we have seen the explosion of the Big Bang and the dishomogeneity of that light are being expanded and are reproducing the void that we have now. So it was only this homogeneity at the beginning of the universe that produced this distribution between condensation of matter and big void.
Wow. Impressive. There's a question here, by the way. Time is over, so for you that have another commitments, you may please leave. But I think Massimo can stay for a few minutes for those interested to go with more questions. There's a very interesting question here about leadership. And the question is, what has been the biggest leadership challenge you had in these kind of major projects?
Okay. You know, I had a boss, you know, even if you are a top manager of a big project, but this project of about 1.5 to billions, our money coming from taxpayer. So they have a lot of responsibility. And my big boss, we had to report. He was a very tough guy, but very intelligent. And he was so intelligent that he received a Nobel Prize for physics. Okay, but we fight every day, and I learned from him a few things. First of all, to find a solution, don't go to bother the boss if you have a solution, and take a. And then he teach me one thing: if you have, you're not sure about solution, he say, come to me with 3 recovery plan, 3 solutions that you consider to be possible, and I will, in 24 hours, I will take a decision which one of the 3 to be implemented. And then he say, yes, but if there's a failure, the failure is yours, not mine. And I learned that when you are manager, responsibility is always on you, no matter what. It's not with your people, it's with you, because you know more than all the others. And if there is somebody that can take a decision, it's you. The other, they know only part. It's very interesting when journalists were asking me, how can you sleep at night with all the problems or projects? I say, very simple. Because I know everything necessary for find a solution. Nobody else knows everything. And so I can sleep because nobody finds a solution during the night when I'm sleeping peacefully. And the following morning, I can think without stress and find a solution. Of course, we had a lot of problems. Okay, we had legal problem. We had I had to fire people, but even more to stop big contract with big companies, and have court cases, arbitration, and all this kind of thing. But I don't think that if you are, as a manager, able to know all what's going on in the project, I think there's not a single drawing of the 2 observatories I've been building and not being on my table. There's not a single document, standard specification, state of work, contract that has not been read by me. If you are the capacity to do that, well, the success will come.
How enlightening. There's another very interesting question here from Diana Salinas. She asked, and I think this question is very interesting because all these projects took many years.
Yeah.
And while you are building like for 8 years, like the lens,
yeah.
and at the same time building the road. So she asks, anytime did you feel you needed to give up?
No, because, let me take Paranal. We had the idea to build this 4 telescope of 8 meter equivalent to 16 meter in 1977. And we spent until 85. And in meantime, we built this prototype, small one. And we start to say, what will be the technology in 20 years from now? Let's design something that is not possible today, even if they give us the money. But in 20 years is, and then you keep going. And if you have a team of people you trust, there is no moment. Let me tell you, I like to start and finish. During this, my 40 year of career in building things, I've been offered other position by other projects, okay, even more with more money and so on. But I never take something before I finish my project. You cannot start the project and then abandon the project because you are the only one that know everything. And it's necessary until the end.
I found it brilliant. There's a question from Alba Lucia. There's many questions. I don't know if we manage to address all of them, but this one is from Alba Lucia Munoz. She asks, what is your strategy when you have to align experts, top class experts from all over the world in a very multicultural environment and align them towards a common goal? What are the strategies you follow to manage to do so?
Yeah, a very good question. And I can tell you that this is a very, very difficult thing when you are involved in a project with many cultures. The European Southern Observatory are 16 countries in Europe. But for example, when I did ALMA, I had 16 countries in Europe. I had America, Canada, Japan, and Taiwan. And I had to manage all this culture in such a way that everybody was able to go in the same path. The secret is to understand them, to be patient. It was very difficult to introduce also the Japanese culture in our project. We already started, then I had to add the Japanese. And that was a very tough time because they have a different way to work. Also, the American and European are different. And you have to, first of all, the secret is to divide the project in such a way that one element is done by a certain community. And then it's easy for them to operate. And then their interface is important, okay? And this was done with ALMA, in which every component, it was attributed to one of the partners. And we were then taking responsibility to put together. So there was a distribution of responsibility to do parts, and then there was a team, multi-national team that was unified to put together and operating.
Makes total sense. There's another question from Juliet Gonzalez. It's a two-part question. One is, which one has been the most difficult situation you had to manage when leading people, when managing teams and people reporting to you in teamwork? And also, what are the lessons learned that you can share with us about managing teams?
Okay. I had difficult moment. For example, there's one case, one engineer that he was not correct in the way to follow his part of a job. We were operating call for tender, and this guy, he went to one of the industry and offered them information if they were paying to him in order to win the call for tender. So this was a very difficult moment. And it was an industry that came to me and said, listen, your engineer have offered me to give information. And this was not easy. Okay. And I managed to solve the problem in the sense that I fired him. Of course, he went to Geneva International Tribunal against me to a fire, but they won. And the very important thing is to show to the industry that there was a case in which I correct immediately, not to give impression that that was possible to do in other cases. So the important thing when you operate with money from taxpayer is when you do competition between industry, have to be done correctly. And I always charge penalty for late delivery. And I always apply late delivery because you have to respect all the industry and not to have to be, they deliver late. I say, no. If you deliver late, you pay me for the fact that you deliver late because others will be able to do so. So it's very important to be felt honest by the people that you look you as a manager. And that I can tell you, all the industry, when sometimes I tell them, why you ask me to pay? When it's so good for you for publicity. You must pay me, not you. But what I always say is everybody, even when they pay penalty, they respect me because they knew that I was doing the correct thing.
Doing the right thing. Wow, so difficult and so important. There are a couple of questions, Massimo, about your younger self.
Yes.
How you were when you started all these projects at the beginning of your career and how you are now. And those questions are about how your leadership style changed, things that you learned that you wouldn't do the same now, things that you would do now or you would tell to your younger self to do now if you were that age, and questions around that topic.
Okay. I started as enthusiast of astronomy, as I say. And I learned during the career that it's fantastic. The enthusiasm has to keep, but also you have to be clear that you are doing something that is a responsibility. You cannot do things that are crazy. And that is very important. A manager that keep a feet on the ground, because when you do not control yourself, the risk of error is very, very big. When my box, the Giacconi Nobel Prize They say to me, don't do mistake, because every mistake you do costs me 20 millions. But so you have to be calm when you have in front of you the problem. And I learned one thing from him also. What the rich man approach. When you have in front of you something that is very difficult, okay, and it can be cause of a disaster of a project if it's not done neither technically correctly nor on time, his approach is to play two contracts for the same thing for two companies in competition. And of course, you throw away money. It looks you throw away money. But in reality, you gain money because you develop the thing such a way that you pay all the R&D, and then the construction is matter of cost. And I've done 2 times, okay, this, and they've been successful because in reality happened that even very difficult thing that maybe impossible, companies are able to do if they're put under pressure with another company competing. The other thing I learned, and it's a very message I try to transmit to my colleagues that are involved in this kind of thing, never ask industry to do things they don't know what is. Take industry and ask them to do what they know how to do, and you take responsibility for the thing that come new. Okay. You cannot take an industry and give to industry, do me a telescope. Nobody is able to do the telescope. There is a company able to do the concrete, one the steel, one the software. My responsibility to transform all this in a telescope is yours. So don't give to industry things they are not in their field.
Wow. Well, there are many questions here, but I want to really thank you, Massimo, for your time, also for the extra time, for your many insightful comments and ideas about your life and how you manage things. As you know, we come, all of us here, from many different industries, and we do many different roles in our organizations. But I think one key lesson that I learn from you every day is that human beings, we are designed to aspire for the highest goals, and that's you are a vivid example of that. Building things that no one ever tried to do and trying to bring humanity to a different level. And I think in our roles and capacities, we can strive, we can dream of and really chase any goal we put in front of ourselves. So the fact that you are here with us is truly inspiring in that direction. And I'm really grateful that people like you are in the planet and help us shape better everything we do in life, whatever is our task. So Massimo, really thank you very much. Thank you all for being here today and for being part of the Westfield community, People, Planet, Profit. We belong to this community. Massimo belongs to the Westfield community. And if you have any more questions, please send it to the team and I will share it with Massimo and we can address them. Here you see some of the people being very grateful in the chat. Massimo, thank you very much for your generosity, your time. Thank you very much. Thank you. Impressive. Well, thank you
too. And if you have a dream, try to transform your dream in reality.
Wow. Thank you. Muchas gracias a todos. también a Gabriel, nuestro intérprete, y a todo el equipo de Westfield. Muchísimas gracias y
Hasta la próxima.
nos vemos pronto. Hasta la próxima.